Hello and welcome to our lesson on ratio and proportion. So what is a ratio exactly? It's actually a synonym for a word that we probably know quite well. A ratio is a quotient of two quantities. And quotient means to divide. And when we divide two quantities, we will often see that represented by a fraction. So a ratio is no different than a fraction, okay? Except that it's sometimes written with different notations. The only difference, but it's just the quotient of two quantities, just dividing two quantities. So, for instance, if we were looking at a ratio of 1 to 2, there are a couple of ways that we could represent that ratio of 1 to 2. So we could write it precisely as a fraction. That would be the typical way to write it. We can also write it with the words 1 to 2, or we can use what we call colon notation. So a ratio of 1 to 2 could be, again, 1 to 2 written out with the words. It could be 1 to 2 written with a colon, or it can be a fraction of 1 over 2. So three ways to represent a ratio of 1 to 2. All of those are acceptable. They all mean to divide the 1 by the 2. Okay? So for instance, if I asked you to write a ratio of 6 to 11 using fractional notation, then a ratio of 6 to 11 would be a fraction of 6 divided by 11. Or the ratio of $15 to $10, written as a fraction in simplest form. Well, if we had $15 as a fraction over $10, then this could reduce in a couple of ways, right? We want to put this in simplest form, so make sure it's reduced. Well, we have units in common in here. So if there's a dollar sign on the top and a dollar sign on the bottom, then we can reduce out those units. And also, 5 and 10 are divisible by 5. So if I divide the numerator and denominator both by 5, then my fraction, my ratio, as a fraction in simplest form, would be without the dollar sign, a 3 over, again, without the dollar sign, 2. So $15 to $10 as a fraction in simplest form, and as a ratio would be 3 to 2. Okay? Now, if we had a ratio for 2.6 to 3.1 in simplest form, again, 2.6 gets divided by 3.1 technically in fraction form. Now, it isn't really proper to leave decimals within fractions in this way, so it might not be obvious that this is something that we can simplify. It might almost look like it's in simplest form, but we don't want to leave those decimals in there. So if I want to simplify this, what I would do to move the decimal is multiply. If I multiply in the same way we can divide the top and the bottom by a number, we can multiply the top and the bottom by a number. We did this when we were getting equivalent fractions before. And so if I multiply the top by 10, 2.6 times 10 is going to move the decimal to make it 26, and 3.1 times 10 is going to move the decimal to make that 31. And 26 and 31 have nothing in common other than 1, which means that is my fraction in the simplest form. So it isn't proper, it's improper to leave decimals within fractions, so fractions should contain whole numbers in their numerators and or denominators. Okay, and I don't have one occur here, but even though we can write ratios as fractions, and fractions are sometimes represented by mixed numbers, ratios are never represented by mixed numbers. So ratios are never represented by mixed numbers. So we strictly will use fractions, proper fractions, or improper fractions. Okay? Just wanted to make sure I pointed those two things out. All right, here's another example. It says to write a ratio of the width to the length of the rectangle. So the width to the length, then it doesn't really matter which one is which here, but I'm going to call this the width, and I'm going to call this the length. So if I wanted a ratio of width to length, that means the width is going to be divided by the length. So the width is 5 feet. Let me make sure this is clear. So width to length in this case is going to be 5 feet, and that goes over 7 feet. And again, we want to make sure that this is in simplest form, so our units that are the same on the top and the bottom would reduce out, making our ratio just 5 to 7. Okay, so 5 to 7 would be that ratio there. And now I boxed in one answer, and I don't know why I didn't box in the others, so now I gotta go back. Don't mind my OCD. All right, here we go. Next, we're looking at something that we call a rate, and a rate is just a special type of ratio. Rates are ratios that compare different kinds of quantities. So not just a number like 5 to 7, or not like a width to a length, where they're both units that are measured in feet, or not like $10 and $15, but they're comparing different kinds of quantities like miles and gallons or dollars per hour or something like that. And because our fraction is going to have two different quantities that are not necessarily measured in the same units, the units will not cancel. So the units don't cancel. When that happens, they should remain in the ratio. Okay? So for example, number 5, it says write the rate as a fraction in simplest form, and it's 2 miles in 20 minutes. So 2 miles in 20 minutes. That would be one way to write that fraction. Again, units are going to have to stay there because they aren't the same. They don't cancel. But in simplest form, we can reduce this. 2 goes into the top and the bottom. So if I divide the numerator and the denominator by 2, then my simplest form is going to be 1 mile in 10 minutes. So 1 mile in 10 minutes is a rate. And it should make sense that that is considered a rate. Okay. The next one, it says write the rate as a fraction in simplest form, and it is $2,160 for 12 weeks. So my $2,160 for 12 weeks. Again, those units aren't going to cancel, but this is going to reduce. And in fact, I think 12 actually divides into 2,160. Let's see. 2,160, does it divide by 12? In fact, it does. So if we were to divide this by 12 by reduce by dividing by 12, then we're going to end up with $180 in 1 week. And when the bottom of the fraction is 1, so 1 unit, we call that a unit rate. And sometimes we will replace the fraction with the word per. So $180 in 1 week. We could also say $180 per week. Okay, so this is an example of what we call a unit rate. So this is highlighter, come on. No, I don't want that color. Okay, $180 per week. That's per 1 week. And I'm just trying to make these correspond. Here we go. That is what we call a unit rate. And sometimes, again, when we have a unit rate like that, we'll use the word per to indicate the division or replace the fraction bar. So $180 in 1 week would be $180 per week. They sort of mean the same thing. Okay. So this per week is division. So $180 divided by 1 week is another way to say that. All right, and hopefully this is familiar. Hopefully these are things you've seen before. Okay, so the last one here, it says write a unit rate for the following. So we have 360 miles per 16 gallons of gas. There's that word per again. That means 360 miles per, we're going to divide by 16 gallons of gas. Okay, if we were to reduce this, let's see. I think we can divide by 4. I'm going to start there. And then we'll probably have to reduce again, but for some reason, that's the biggest number that's jumping out to me. Actually, I think 8's going to go in. Yeah, 8 will go in. Let's do that. Maybe 16 goes in. Nope, whatever. Let me start small. Okay, 8's going to go in. So 360 divided by 8, let me just not goof anything up here, is 45. So 45 miles. And then 16 divided by 8 is going to be 2. So 45 miles in 2 gallons is as far as this is going to reduce. So to reduce in the typical sense of the word, but if I'm asked to make this a unit rate, that means I need the bottom of my fraction to be a 1. So what I'm actually going to do to make the bottom have a 1 is I'm going to have to divide by 2, which means I have to take the top and divide it by 2 as well, or basically take the 45 miles and divide by 2 gallons, just like the fraction is telling us to do. And when we do that, 45 divided by 2 is going to give me a decimal. So 45 divided by 2 is going to give me 22.5. So 22.5 miles, and then the 2 divided by 2 gives me 1 gallon. Now again, it's kind of it's improper to leave a decimal in a fraction like that, so this one you would see rewritten as 22.5 miles per gallon, and we actually have an abbreviation for miles per gallon that you've probably seen before. So we can say more succinctly 22.5 miles per gallon, MPG. Okay, that's miles per gallon. So that would be the unit rate for that situation. Now, if I just said a fraction in simplest form, then we would have stopped right here. That's as far down as that technically reduces. But to make it a unit rate, we need the bottom of the fraction to be 1. So we actually would divide that out completely and say it's 22.5 miles per gallon. Okay, so we have ratios, which are just fractions. We have rates, which are fractions that compare different quantities. That's what we just saw. And then we have proportions. So a proportion is a statement that two ratios or rates are equal. So that means we have two fractions that are going to be equal. So if one rate or ratio or fraction is equal to another, then it is said that the two are proportional. The two are said to be proportional. So if you have a fraction equal to another, the two fractions are proportional. Or a ratio equal to another, the two ratios are proportional. And if two rates or ratios or fractions are proportional, then there's a really nice feature that helps us to do some solving as we progress here. The cross products of proportional fractions will be equal. Okay, so let's look at this example here. For instance, 5 over 6 equals 10 over 12. We could read this as 5 is to 6 as 10 is to 12. Okay, but this is an example of a proportion. So this is a true proportion. And how do I know that it's a true proportion? It represents a true statement. I know this because if I was to cross multiply, if I was to find the cross products, they're going to be the same. So if I cross multiplied here, 6 times 10 makes 60. And if I was to cross multiply here, 5 times 12 also makes 60. That's going to happen every time you have one fraction equal to another. So I know that this represents a true proportion. I know that those two fractions are proportional because their cross products are equal. Okay? So let's look at a couple of examples. It says, first, let's just write a proportion. For 5 hits is to 9 at-bats, as 20 hits is to 36 at-bats. So just in order here, 5 is to 9, so 5 hits is to 9 at-bats, as 20 is to 36. So as 20 hits is to 36 at-bats. And again, those units should technically be in there. But we want to make sure that this is actually a proportion, that it's actually one fraction equal to another, and we can verify that using our cross product. So if I was to cross multiply here, 20 times 9, and then cross multiply here, 5 times 36, just to verify, those two should be equal. Well, 20 times 9 I know is 180. 36 times 5, wouldn't you know, also 180. So just to verify that this is a true proportion. Okay, so this is, I don't know, let me move this. I don't want this to clog up the work. I just want to show that we're checking here that this is a true proportion. Okay, so similar then for number 9, we're writing a proportion for 12 diamonds. 12 diamonds is to 5 rubies. So 5 rubies. So 12 is to 5 as 4 is to 5, or 15, sorry, as 4 is to 5. So 4 diamonds and 5 rubies. And if this is a proportion, then these cross products should be equal. So let me just do a little check here. 4 times 15. 4 times 15 should equal 12 times 5. And 4 times 15 is 60. 12 times 5 is 60. Since those are the same, we're good. We've got a true proportion. Okay? Now, straightforward, are these true statements? Here's this proportion true. If we cross multiply here, we get 12. If we cross multiply here, we get 12. Definitely equal. So yes. And then here, maybe not as obvious. Like, I can look at 2/3 and 4/6, and you're probably seeing it too. If you took 4/6 and reduced it, it would reduce down to 2/3, so it's pretty easy to see that those are going to be proportional. Maybe it's not as clear for something like this, but we can do the same thing. Multiply 7 times 2.9, multiply 5 by 4.1, and compare the results. So 7 times 2.9 is going to be 20.3, and 5 times 4.1 is going to give us 20.5, and those are definitely not the same, which means no, that's not a true proportion. Okay, that means we should not be having an equal sign in between those because they're not the same. So, no, not supposed to be true. But I don't want to take out my work. Okay, now the nice feature, I mean, it's nice to be able to look at a proportion and cross multiply to verify that it's actually a true statement. But the nicer feature of the cross products having to be equal is that we can use cross multiplication to find unknowns in proportions. So if we have a proportion, we should always be thinking to cross multiply. So if we're going to try to find an unknown, we want to make sure we set the cross products equal to one another. And that's going to create an equation where we will divide to solve for the unknown in that equation. So for instance, it says 7 is to n as 6 is to 5. So 7 is to n is 7 over n. 6 is to 5 is 6 over 5. And that is telling us this should be a proportion. So if this is a proportion, again, that means that the cross products have to be equal. So if I cross multiply here, 6 times n is 6n. If I cross multiply here, 5 times 7 is 35. So if I want to find that unknown, then I just need to solve for n. n is being multiplied by 6, so I would divide both sides by 6. That goes away, and that tells me that n, my unknown, has to be 35 over 6. And we have solved a proportion, okay, solved for an unknown in a proportion. And we can do the same thing here. It says 51 is to 34. And I'm going to run out of space here. 51 is to 34 as 3 is to what? And let me get this as 3 is to what? So 3 is to what? We don't know. Let's call it n or x or some variable here that we don't know. Okay, if this is a proportion, then these cross products have to be equal. So 34 times 3, again, let me just not do anything silly, is 102. And 51 times n is 51n. So if I want to know what that unknown is, if I want to solve for n, I got to get rid of multiply by 51, which is divide by 51. And once that cancels, I can see that my unknown has to be 2. All right, 102 divided by 51 is 2. So there's my unknown there. And sometimes instead of giving you the words, it's just a straightforward equation. And I don't know if this is going to fit here. I did not space this out very well for myself, but let me cross multiply. 3 times 0.8, and I can do this in my head, but I don't want to goof. Okay, so 2.4, I knew that, has to equal 1.5 times n, so that's just going to be 1.5n. Again, if I want to solve for my unknown, I got to get rid of the multiply by dividing. So I'm going to divide both sides by 1.5, and that tells me that my unknown n is 2.4 divided by 1.5. 2.4 divided by 1.5. Oops, not 105. Not 15. Come on, fat fingers. All right, 1.6. So my unknown is 1.6. Okay, last one, which I think is where something like this concept is a little more useful. It says 5 miles corresponds with 2 inches on a map. How many miles correspond with 7 inches on a map? So we have 5 miles corresponding to 2 inches. So one ratio is 5 miles to 2 inches. Okay, and that's going to be proportional to how many miles corresponding with 7 inches. When I go to write my second fraction, I know 7 inches has to go here because we want our fractions to correspond, right? It's miles to inches both times. The question is how many miles? We don't know. And so what we're going to put in that spot where we have an unknown, again, is an n. So when I go to cross multiply here, n times 2 is going to be 2n. And then 5 times 7 is going to be 35. And so dividing both sides by 2, we see that our unknown is 35 over 2. And that's going to be a decimal, but that's okay. So 17.5, and that was a number of miles. So we're going to say 17.5 miles on the map is a 7. Oops, go away, calculator. 7 inches. Okay? So there it is. Rates, which are fractions, or ratios, which are fractions, rates, which are fractions comparing different quantities, and then proportions, meaning you have one rate equal to another or one fraction equal to another. Okay? Hopefully you've got enough here to get going on your practice, but as always, if you need any extra help, then just reach out. Till next time, take care.